Hi, I'm Dave Mueller, retired hydrologist from the U.S. Geological Survey and founder of Genesis Hydrotech. In this video, I want to describe the QRev toolbar and the main tab. In the previous video, we took just a quick look at the user interface. So in this video, we're going to go into more detail about the toolbar and the main tab, and then in subsequent videos, we'll go into each tab in detail. One of the things that you notice is the tab icons and colors. Green text with a green check mark indicates that the data presented in this tab has passed all the internal quality checks. Yellow or orange text and a triangle with an exclamation mark indicates that the data presented in this tab has failed some of the internal quality checks and the user should evaluate that data. Red text with a red square and an exclamation mark indicates that the data presented in this tab has failed some internal quality checks, and the failure may have substantial effect on the resulting discharge. The user needs to address these issues. Blue text with any of the other icons indicates that the user has made a change from original settings. If a change is made, a message will be added, and the user should add a corresponding comment to document the reason for the change. Changing the text to blue provides a reviewer a quick way to see if any changes have been made to the original value. Gray text indicates that the tab is inactive because there are no data to display. And black text with no icon indicates a feature that has no automated quality assurance checks. So let's begin by looking at the toolbar. One of the first icons we need to consider is how to load or open a measurement. If we click on the folder in the top left, we get a dialog that allows us to navigate to our appropriate folder and select our measurement. In this case, we'll select measurement number 9. It's a TRDI file, so all we do is click on the MMT file and click open, or simply double click on the MMT file. Be prompted, do you want to load only check transects? If this was a longer measurement, you had some transects that weren't valid and you didn't want to use, you wouldn't have to load those. If they were unchecked in Wind River 2, you could only load those transects that were checked in Wind River 2. However, we're just going to say no here and load everything. And it'll take just a minute for it to process the data and load. And now we have the first transect shown in our main window. I want to continue with the toolbar, but I want to jump to the far opposite end and click on what I think may be one of the most important icons on the toolbar, and that is the Help menu. If we click on the Help icon, we're going to get a pop-up in our internet browser of the user manual, the technical manual, a change log, and even about QRevInt. So this is where you can find almost anything you need. Surely at the end of all these videos, you're going to forget some of what we've covered. You can come back to the user's manual and go down. It's all itemized in chapters and subchapters, and you can find nearly everything that we're going to talk about in these videos. If you need more technical details, you can click on the technical manual, and that will get into some of the algorithms that we use to identify outliers to process the data. Okay, now back to our toolbar. If we're done with our measurement, we can save our measurement. We would click the Save icon, and again we'd get a similar dialog, but this would allow us to save the measurement. You'll notice that you've got an automatic name for the measurement. It is the year, the month, the day, and the hour, minute, and second, and then the version of QRev that you're currently running, and then an underscore QRev.mat. The underscore QRev.mat is used when you load a save file so that QRev knows that, hey, this is a QRev save file and I know what to do with it. So we can click Save, and we get prompted, would you like to save a PDF summary report? I'm going to cover that option in just a bit, so for the interest of time, I'm going to say no. The data have now been saved. It's saved a underscore QRev.mat file that contains all the raw and processed data in a MATLAB type format. It also has saved an underscore QRev.xml file that is an XML style format that can be used to load the data into your corporate database. In addition, if we had said yes to the question about do I want a PDF summary report, it would have created a PDF file with a summary report of this measurement. The next icon is an options icon. And there are many options that you can choose to set. First is the units, whether you want English units or SI units. The next is the default x-axis. So whether you want length or you want ensembles as the default, you can always change that at a later time, but this is just the default when you first load a measurement. Then the color map. The Viridis is the default for QRev because it tends to provide a better representation of the data. It doesn't overemphasize highs and lows. However, you have the option to choose Jet, which is the traditional color scheme that was used in Wind River 2 and River Surveyor Live. We have a save option. You can save all the transects, or if you had gone in and unchecked some of the transects because they weren't valid, then you could save, your save file would only include those checked transects. You can choose to be prompted to give the measurement a rating when you save. This next option, Save Style Sheet with Data, was used previously so that there was a style sheet, and when you clicked on it, it would open in the browser and show the data from the XML file in a nice summary report. That has been by and large now replaced with the PDF summary report. The export mean cross-section means that all the transects will be mapped onto a common cross-section and averaged, and you will get one cross-section out of all the transects that you've collected, and that data will be included in the XML file. The Save PDF Summary Report, you have three options. You can set it to never save it. You can set it, which I recommend, to prompt on save, or you can save it every time you save a measurement. Under extrapolation, we have an option to check or uncheck discharge weighted. I recommend that you use discharge weighted being checked. What that means is when we compute the extrapolation methods, we're going to give more weight to the larger cells and the cells where the majority of the flow occurs, and less weight to perhaps the smaller cells or those on the edges that contain less discharge. Water track and bottom track filters have an option here that we can compute those filters for each transect or for the entire measurement. Generally, we do it by transect. QRev also contains two uncertainty models. One is the original QRev model. The other is the Arsen model that was developed by a group out of France. We can change the date format depending on your agency, your country, or your specifications. Currently, it is set to year, month, day, but you could change it to any combination of those in any order with any slashes or dots or whatever you want for a delimiter in between. And finally, it's the map tab, and you can choose to show the map tab or not to show the map tab. We'll cover the map tab in one of the last videos, as it's a little more detailed analysis and doesn't really associate with processing discharge, but could be used when you're using your measurements for other purposes. The next tab is one that I think is important. It's an add comment. Here, As you're processing the data and you see something that you want to make the reviewer or you want to document, you can add a comment. The comment will then be saved. It identifies the tab you are looking at, the date and time, and the user who made that comment. So if I click OK, and then I come down to comments, you will see that this one that I just added is now in the comments. The next tab, the screen check mark, allows you to choose to use or not use a particular transect in the measurement. So if for some reason I thought a transect was invalid, I could uncheck that transect. And then when I say OK, it will process the measurement with only 3 transects. In this case, I'm using GPS for my reference, and I get a warning that says transects selected are not reciprocal transects. So that's probably not a good idea. And I can go back and turn it on. The next portion of the toolbar is the navigation reference. And this shows the navigation reference currently being used. In this case, it's GGA. It's in bold. However, I could change it to bottom track by simply clicking bottom track. It will recompute my measurement now using bottom track. Likewise, I could choose VTG. We'll go back to GGA since that was the original setting. The next one is composite tracks. What composite tracks does is if whatever you've selected over here as your navigation reference is invalid, then it will default to one of the other available navigation references automatically just for those invalid transects. So it would use the one you selected as long as it's valid, and then if it's invalid, it would go through a logic and pick one of the other options. Finally, we have a series of 4 icons that allow you to manipulate the graphics. The first one returns as a home. It returns everything to the default. So we'll save that one for last. Let's first look at zoom. So I can click on zoom and then I can draw a window and zoom in on my data. Likewise, I can hold the right click key down and do a zoom out and zoom out on my data. I can come up and click this icon so then I can pan through my data. And finally, if I pick the eye, that's a data cursor. I can actually come in here and click on particular locations of data and get their value. And this works in all of the plots. So I could zoom on this plot as well. Or if I wanted to look at something in great detail on the extrapolation plot, I could zoom on it. These plots as they are in this particular tab, in the main tab, they're not tied together, so they're independent. Finally, if I want to go back and say, well, let's reset everything back the way it was, I can click home and it will reset the graphics back to the default settings. The next icon, this plus icon, lets you add the edge and the top and bottom estimates to this color contour plot. The dashed line in white indicates the boundary of the measured data, and then anything outside that line has been estimated via extrapolation or using the edge computation algorithms. Finally, the little globe here, if you have GPS data, you can click on the globe and it will open the measurement in Google Earth. And you can see where this particular measurement was made. Actually, it was made in St. Louis, just downstream from the arch. Before we move into looking at the main tab and its associated subtabs, I wanted to share with you the keyboard shortcuts that are available in QRev. Rather than clicking on icons, if you hit Control F, you can open a file. Control O opens the option dialog. Control S, the save. Control N lets you add a note or a comment. Control Q opens the Select Discharge Transects dialog. Control B switches to bottom track, Control G to GGA, Control V to VTG. Then we can change our x-axis. So Control E uses ensembles, Control L switches it to length, Control T switches it to time. If you're in the Advanced Graph tab that we'll talk about later in these videos, a Control A will show the correlation and return signal strength indicator data below the side lobe. Control U shows the extrapolated speed on the final speed contour plot. An up arrow selects the transect above the currently selected transect, and down arrow selects the transect below the currently selected transect. So now let's look at the main tab and the associated subtabs. The table at the top provides all the summary information from the discharge measurement, including the total discharge, the top estimated or extrapolated discharge, the part that was actually measured, then the bottom extrapolated, and the left and right edge estimates. It also gives you a difference for each transect from the average discharge. We can change what's plotted in these two figures by simply clicking on one of the transects in that table, or we can use the up arrow or down arrow shortcut keys to move up or down through the table. Whichever transect is highlighted in the table is also highlighted with a bolder line in the discharge time series plot. Again, we could use any of the graphics controls here to zoom in on the graphics to evaluate things that are going on. We can click the comments, and we can see in this case we actually have some comments that were put in Wind River 2 that have been brought in. We also noticed previously when I clicked the save icon, it put a message in our comments that says, I saved this message at this date and time, and the saved discharge was this value with an uncertainty of 3.2. That uncertainty right now is shown here in this table because we have selected the original QRev uncertainty model. If we select the RSIN model, it will recompute the uncertainty, and we get a lollipop plot that shows relatively where most of our uncertainty has come from. You can see there's a slight difference between the two, from 3.2 to 4.4. The uncertainty models are not exact, but they're usually very close. The RSIN probably has the better scientific foundation and methods for estimating uncertainty, but they both do a reasonable job. If we click on the Details tab, we get additional details about the measurement. We get the width for each transect, as well as the average width and the left and right distance, the area, the average boat speed, the course made good, the actual direction of the transect, and then a mean velocity computed as discharge over area, and then the average water direction. So we would expect the water direction to be the same in most of our transects. A change here of 2.4% seems to be directionally biased, whether we go left to right or right to left. That could be a bit of a compass error, but probably not significant. If we click on the Pre-Measurement tab, this is where we could edit our site name, our site number, the persons that collected the data, if we have a measurement number associated with it, if we have a starting stage, an ending stage, and then finally whatever the mean stage for that measurement is. It also tells us about the instrument that we used to collect the data. It says that we did a system test and there were no fails. We did a compass calibration and the evaluation showed that it was within 2 degrees. We did a moving bed test and there was a moving bed. We had an independent temperature reading that was very close to the ADCP temperature reading. We entered a magnetic variation of -3.2 and we had no heading offset. The heading offset is generally used when you have an external heading source such as a GPS compass. Under the Settings tab, we see all of the different settings associated with each transect, the distance for the left and right edge, the shape of the left and right edge, the draft, which should be consistent between our transects, the depth that the ADCP is in the water, any excluded distance due to flow disturbance that we've set based on the instrument type. Then for our depth, we get the reference. These are using bottom track. It could use vertical beam or it could use a composite. In this case, it is using a composite with bottom track being primary and then the vertical beam being secondary. We see that our navigation reference is GGA and we have composite tracks turned off. In this particular measurement, our top and bottom method are both power and the exponent is the default exponent, 0.1667. Finally, we get information on the ADCP. Our serial number, the manufacturer, the model, the firmware, the frequency, the depth cell size. With the newer ADCPs, the depth cells are often dynamic, so we get a range of depth cell sizes, the water mode and bottom mode, which also could vary, and if they did vary, they would just show various.